Hey, hi everyone. Welcome to Code Type Management. So in the last lecture, we have discussed the foundations of machine learning models. Okay. So in this lecture, we will basically discuss about the linear regression. So the practical thing of the linear regression, how it's being implemented. Okay. So that's the part of you can say the supervised learning. So today we will deep dive into it through the practical example. Okay. So in the last lecture, I have given the example, the house price prediction. So that one only we will use. So I have used this houseprice.csv file. If you want, then just comment below. I will give you that CSV dataset as well. So here we had this area and price, these two particular columns, and we have like 100 rows. Like here you can see the in the first row, the column names are there. Then the data row is like from second row to 101. So 100 100 row data is actually there. And in the anaconda, like in this jupyter, I have created one environments, and inside that I have this code tab management folder, and inside this actually I have kept this demo IPUNV file and the CSV file, so that it will get the data, like get the CSV file properly. Okay, if you will create any another folder, then you need to give the proper path. Okay, so one by one I'm just explaining the how we have implemented this. So in this practical session, we are going to build our very first machine learning model. So until now we have learned the theory of machine learning, but now it's time to apply it. So our project is house price prediction. So we will use the linear regression. So like one of the simplest yet most powerful machine learning algorithm, you can say, so for predicting continuous values. Okay, so you will use the linear regression here. So by the end of this notebook, like you will understand the complete workflow, like from loading the data to training a model, making predictions and evaluating its performance. Okay, so let's begin. So first of all, we have to import the libraries. Okay, so before writing any machine learning code, we need to import the required Python libraries. So let's understand each one. First, pandas, you can say import pandas as PD, right? So pandas basically helps us work with the structured data, so such as CSV files. So it allows us to load, filter, and manipulate the datasets easily. Okay. Next is NumPy. So NumPy is used for numerical computations. Most like machine learning libraries internally use the NumPy arrays because they are much faster than standard Python lists. Next, we have the matplotlib. So matplotlib basically helps us visualize our data. So later we will create a graph showing the relationship between house area and house price. Okay. And next we import the trend test split from the scikit-learn. So this function basically divides our dataset into two parts. One is training data, which is basically used to teach the model, and another is testing data, which is used to evaluate how well the model performs on unseen data. So then we import the linear regression from again scikit-learn. Okay, so that is the linear regression class, right? So this class contains the implementation of linear regression algorithm. So finally, we imported the R2 score from the scikit-learn. So R2 score basically tells us how well our model explains the variation in the target values. So the closer the value is to 1, that suggest like the better uh, model we have created. Okay, whenever you will get the closer value to 1, that means your model is good enough. Okay, so that's the case. So first of all, we need to load the data set. So I have shown you, we have the house price.csv file in that folder, like in our code tab management folder, and we have just loaded the data. So here you can see pd.read csv, that basically reads a csv file and stores it in the pandas data frame. So in the sort I have written as df, to mean it as it is a data frame. Okay, so that is the pandas data frame. So what is pandas like data frame? So data frame is similar to any Excel spreadsheet where data is organized into rows and columns. So after loading the data set, we call the head. Okay, so the df.head. So the head function actually displays the first 5 rows of the dataset. So you can run this. So I have ran. So okay, first I need to run this. Okay, like this imported. Now I am running this. Okay, now you can see the first 5 rows of the main CSV data it came. Okay, so this is always the first thing you should do after loading the data, because it allows you to verify the file loaded correctly. So column names are correct, data looks reasonable, like that. Okay, so in our data set we have two columns. You can see area and price, right? So area means the size of the house, and price is the selling price of the house. So our goal is to train a model that learns the relationship between the two columns. Okay, now we have to collect the dataset information. Okay, so again, if I'll run, so you can see that we have used the info function, right? So this function basically gives us an overview of the dataset. So it tells us the number of the rows. So you can see here 100 entries, 0 to 99. So 100 entries are there. So after that, like number of columns, like here you can see the columns. Okay, so we have the two columns. So then the data types of each column, here you can see both are int 64, and whether any values are missing. So here we can see that non-null. Okay, and non-null values are 100. Okay, and count also, here it is showing that non-null. And again here it is we got that data types like int 64, like for two columns. Okay, total two columns. Okay, now memory usage also we got from that. Okay, so this step actually important because machine learning models expect clean and complete data. So if there are missing values or incorrect data types, we need to fix them before training. Okay, now we need to get some statistical summary. Okay, so again from the data frame, like we have called the describe function. So to get the statistical information, actually we use that function. So this function calculates important statistics for numerical columns. Like you can see here, like count, mean, standard deviation, minimum, 25%, 50%, 75%, max. Okay, so this 25%, 50%, 75% means these are the quartiles. Okay, so these statistics actually helps us understand the overall distribution of the data. So for example, if the maximum house area is much larger than the average, it may indicate some outliers, right? So here you can see mean is 2521, okay, but max is 4000. Okay, so it's quite good, as our minimum one is 631. So as far as it is good. Okay, now we have to do the feature selection. Okay, so like like in the last lecture I have discussed about what is the feature, what is the level. Okay, so like in machine learning, input variables are called as features, and output variables are called as the labels or targets. So here the area column is our feature because it helps predict the price, and the price column is our target because that's what we want the model to predict. So we store the feature in X and the target in Y, right? You can see. So this naming convention is basically widely used in machine learning. Next we have to do like train test split. So now we split the dataset into training and testing sets. So we use the train test split function from scikit-learn. So here we have kept the test size as 0.2, right? So that means the 25 to like 20% of data will be used for testing, and the remaining 80% will be used for training. So why don't we train on all the data? Because we need to test whether the model can make predictions on new or unseen data. And the random state we have given as 42. Okay, so what does it mean? So it ensures that every time we run this notebook, the split remains the same. So that makes our results reproducible. Okay, now again, okay, that need to run. Now I will run this. Okay. So like we are training the model here. So now comes the most important step here, which is training the model. Okay. So first we create an object of the linear regression class. Okay. So then we call the fit method. So basically here in the model we have actually created the object, and here from here we are calling the fit method. So the algorithm looks at the training data and finds the best fit line that basically minimizes the prediction error. So after this step, the model has learned the relationship between house area and the house price. Okay. Now we are making the prediction. So now let's test our trend model. Okay. So we use the predict method to estimate house prices from for the testing data, right? So these predictions are stored in the variable pred, right? So next we calculate the r2 square, like r2 score. Okay. So so r2 basically measures how well our predictions match the actual values. So we got the score as like 0.978. Okay. So like just you need to know that a score close to 1, that actually indicates an excellent model, and for our case it is more than 0.95, so it our model is good enough. Okay. If it will be like 0.8 to 0.9, it's generally considered good, and if a score near 0, that means the model is no better than simply predicting the average. So this gives us a quick measure of model quality. So our model quality is very good, right? Now we will do the visualization finally. So finally, here we are just visualizing our result. So the scatter plot, we have called the scatter, right? From the matplotlib, plot was our object, and from that actually we have called the scatter. So the scatter plot represents the actual data points. So each dot corresponds to a house in the testing data set. So the line represents the predictions made by our linear regression model. So if the line passes close to most of the points, you can see most of the points, like our line, most of the points are like touched with our lines. Okay. So the line represents the predictions made by our linear regression model. So you just know, like if the line passes close to most of the points, so it means basically the model has captured the relationship well. So visualization is a powerful way to understand the model performance, because it allows us to see whether the model is fitting the data appropriately or missing important patterns. Okay. So congratulations again, like you have successfully built your first machine learning model. So in this lecture, we just learned how to load a data set, explore the data, select the features and target variables, split the data into training and testing sets, train a linear regression model, make predictions, evaluate the model using the R2 score, and visualize the regression line. Okay, so this is the standard workflow you will follow for many machine learning algorithms. So in the next lesson, we will dive deeper into linear regression. We will understand the mathematics behind it, like we will explore evaluation metrics like MAE, MSE, RMSE, and work with a richer real world dataset. Okay, so just to do like, share, and subscribe for motivating me. We will deep dive more and more to cover everything. Okay.